On 50.
Can you, like, multiply the third? Or
You really-
divide by 2? Is that a multiply?
What happened?
And then you would just do, like, 8 times 10 minus 3.
Yeah, because if you cube both sides, you wind up with 8 times, yeah, the 10 minus. Is that what you got?
Yeah.
Going that route, so then you get 80. Stop the whispering, do something, and pay attention. I don't know what I'm supposed to do. All right. Add 24, subtract 2. So is it 78 is 23x. It's another real god-awful fraction. You just got to substitute and check it. That's the easiest way to go on that one. All right. Some of these, to be honest with you, a lot of these when you get into coefficient up front, are you going to see that very often? Probably not. Okay. It's more along the lines of, do you know what to do with stuff like this? Do you know what to do when it's or root equal root? Things like that. All right. So it's going to be a little bit cleaner. All right, let's switch to the, make sure your name's on that one. Switch to the worksheet then. Send that one up, and let's look at the worksheet then. Let's start with 27. Then I heard someone say 17, correct?
Yeah.
All right. All right. First thing we're going to do.
Wait.
What's the first thing you're going to do? Add 1. We have 2 root x plus 4. Don't get lost in the fractions over here. So it's x plus 4. When you're multiplying these things out, even though you have fraction, just spoil it. It's x squared over 4 plus x over 4 plus x over 4. Okay, x over 2 times 1/2 is x over 4. Okay, so you get x over 4 plus x over 4 would be 2x over 4, so it's x over 2. All right. Plus. And then it's equals on that. And then last one, and then it's 1/2 times 1/2 is 1/4. Okay? No, keep going. Move everything over. You have to subtract the x, so instead of leaving it in terms of this, I'm going to put it automatically as with the denominator of 2. So that's the same thing as 4x over 2. No, it's not. It's 2 over 2. Sorry. Thinking ahead. 2x over 2 is the same thing as x. Do you agree?
Yeah.
All right. So when I subtract that over, you wind up with x over 4, x squared over 4 plus. Well, when I subtract it, it gets minus x over 2. Here I have a fourth, or a 4. In order to get that in the denominator of 4, it's going to be 16 over 4. Do you agree?
Yeah.
Okay. Subtract that over, you get minus 15 over 4. All right. So once again, what you wind up with here is just some nasty looking fraction stuff. So use quadratic. Your A value is 1/4, B is -1/2, and C is -15/4. This is 1/2 plus or minus square root 1/2 squared minus 4 times 1/4 times -15/4. All over 2 times 1/4. All right. Now, as you check through this, you're going to wind up with 1/2 squared is 1/4. That drops out, and you wind up with 1/4 plus 15/4. All over 1/2. Okay? What's 1/4 plus 15/4? 16/4. What's 16 divided by 4?
4.
What's the square root of 4?
2.
So you have 1/2 plus or minus 2 divided by 1/2. All right. So when you do that in your calculator, find both solutions. Just type it like this: 0.5 plus 2 over 0.5, 0.5 minus 2 over 0.5. Those give you your two solutions. Check to see which, if either one of them work. If neither one of them work, or one of them extraneous. You can't simplify over addition.
Is this going to be on the test?
You still have to know how to use quadratic formula if you need to. And you still have to add and subtract, right? Okay. Math is cumulative, remember that. And that's how you go from there. So it's 2.5 divided by half, so that's what, 125? And then it's -1.5 divided by half, which is 0.75, -7.75. You just substitute back in and check and see if either one of them works. Ladies, I know your conversations are probably really important, but you have a test tomorrow. So let's stop there, okay? All right. You got to remember quadratic. Something does not go away. You will see quadratic throughout, intermittently throughout the rest of the second semester. You will see it with trig functions as well. All right. What was the other one you guys were looking at? 17, I thought someone said. 17 is a little bit cleaner for some of the ones that we've been looking at, because when you don't wind up with extra variables on the right side, so it's going to be a little bit easier to work with. So right off the bat, subtract 4. You get 2 cube root of 1 minus 3x equals 2. Divide both sides by 2. You get cube root of 1 minus 3x equals 1. Cube it. 1 minus 3x is 1. Subtract 1, add 3x, 0 equals 3x, x is 0. So, then you just got to check to see if it works. Yeah, why can't it? I'm not divided by 0 anywhere. So then you check 2 times the cube root of 1 plus 4. Well, that's 2 plus 4, and does that equal 6? Yeah. That's how you check to see if it works. It is okay. It's completely all right to have x equal to 0. It's fine. Nothing wrong with that. It happens.
Okay. Like, if you have a negative thing under a square root, and like both sides have that, and then they both equal like an error, would it be a solution, or would it be a real solution?
I think we're only looking for real solutions. Because you're right, you could wind up with like the square root of -8 equals the square root of -8. I believe everything that I've shown you guys, we're only looking for real solutions. On the test and stuff, it'll just be real solutions. So if it did happen, it is a solution, but it's not a real solution. Because I don't think so remember when I went over this section, all of our answers never dealt with I. So in that case, you'd have to deal with an I. I mean, if it works, cool, but I'm not going to look for any imaginaries. That's like the one thing, because you keep saying, well, quadratic, you do that. Well, imaginaries is one of the other things that you learn, but you don't always go back to. It's one of the few things in math that doesn't always show up. Okay. Yeah.
So you take like inverted or whatever of like negative number?
Yes. You can take nth roots You can take odd nth roots of negative numbers. Because when you look at what that means, if you take -2 and you are cubing it, that means it's -2 times -2 times -2. Anytime you have an odd amount of negatives multiplied together, your answer will always be negative.
Well, yeah, but like,
What number?
well, it's like number 14.
Okay. Now, on 14, I can see something right away. And you might have overlooked it. When you subtract 1 over, what is the number in front of the nth root that you don't see? It's -1. Divide both sides by the negative and it should go away. Tells you right here. And usually that's what people forget, that when you rewrite the problem out, you probably forgot the negative.
No, I just actually 3.
Oh, yeah. So now you wind up with -4. So now in order to get rid of that -1, you divide both sides by that -1. Oops, sorry. So that's where you just get the third root of 5x plus 4 is 4. Okay. In this problem, if it was negatives, it would still work because you could take a third root of a negative number, and then you're multiplying it by another negative to turn it back into positive. So you just got to watch those signs. So here you just third power on both sides. 5x plus 4 is 64. 5x is 60. X is 12. Did this one work? 64 cube root negative, be -4 plus 1. Yeah, -3. This one does work. Okay. Remember, anytime you see a negative out in front of something that there isn't a number next to it, it's implying there's the number 1. Okay. Did any of this make any sense for you? Because I know you missed out on a few of these. Good. Good. Did you watch anything online? I thought you could at least look at that. What was the one you said? 15? 15? Subtract the 5 right away from both sides. So you have 3x plus 1 equals -2. Grab my nth root. Cube both sides. So you have 3x plus 1 is -8. Subtract the 1. 3x is -9. X is -3. Once again, it's okay that it's a negative number. When I substitute back up top here, we have cube root of 3 times -3 plus 1. So that's -9 plus 1, so it's the cube root of -8, which is fine. You can do that. You get -2 plus 5 is 3, and it works. All right. So you just gotta watch your signs, especially when you have the nth roots. If you get negatives, remember, it's okay to have an odd nth root of a negative. Perfectly fine. There's nothing wrong with that.
So to get rid of the root thing, you just like cube it by that number.
Yeah.
But it was like a mystery. Like.
Yep, it's fifth it. Yes, exactly. Exactly. You raise it to that nth power. How's that? All right. And that works for any one of these. Absolutely. Absolutely. Any others? Not so bad. Make sure your names are on that. Pass that up.
We can check them early.
Yeah, that's fine. You can go on the worksheet. I don't need a worksheet.
Just for you.
You took mine first.
She threw it out in front of me.
Yeah, she was like, no, go.
Did it feel better?
I didn't.
I think I did. All right.
So maybe I won't do it.
So, with the time that we have left, what I'd like to do is I want to go over a couple of review things with you guys. Get ready for the test. All right, take a few minutes. Substitute those through. So we have same base, different exponents you subtract. Who wins in the battle, a 2 or a 1/2?
2.
Would you rather have $2 or 50 cents? $2. So we wind up with 4x to the 3x. Okay. On the test tomorrow, I will ask you guys to leave things in exponential form. So that will be okay. Number 15. Remember, the trick is when you have the 6th root or any nth root of a whole bunch of junk, you're figuring out which one of those has a perfect 6th and which ones can you take out. Okay. So can I take the 6th root of 6?
Oh, I mean that you said yes.
I cannot. 6 is not a perfect 6th. Okay? 6 is not a perfect 6th root. Now, if it was like the cube root of 8, yes. You can take the cube root of 8. 6th root of 6, no. It's not a perfect 6th. 6 goes into 6 how many times? Anything left over? Take out 1x. 6 goes into 7 how many times? How many are left over? 1 out, 1 in. 6 goes into 10 how many times? How many are left over?
4.
Are you going to get that problem wrong tomorrow? No. Okay. Right. 16 is very similar to it. Yeah, it is. 16 is very, very similar to that. You're doing the exact same process. You're not changing it up any. What you've got there is you just have to worry about setting it up as, break it apart in smaller chunks. You have the cube root of 4 times the cube root of a to the 6th plus a cube root 108 cube root of a to the 3rd. Just break it into easier chunks if you have to. If it doesn't appear to look just like number 15 did, break it into easier parts. So can you simplify the cube root of 4? No. Cube root of a to the 6th. It's a squared. So it becomes a squared cube root of 4. All right. Cube root of 108. Is there a perfect cube that hides in the 108? 27 times what? 4. So this is the same thing as cube root of 27 times the cube root of 4. What's the cube root of 27? 3. And what's the cube root of a cube? A. So you wind up with a times a, which is a squared. Oh, a squared cube root 4 plus 3a squared cube root 4 is how many? Your answer is, whoops, 4a squared cube root 4. What happens? Nothing's canceling out. Oh, you mean here?
No. Oh, you added 3 set. Okay.
Okay. Nothing canceled out here, guys. Nothing canceled out.
Okay, so it's your first copy.
What is there like different? Like it's 4x squared over 6x.
As long as these two guys, if these two guys are the same base, then you can work it. If they're not the same base, then you can't really do anything. You just try to simplify each term, see if you can do anything with that. That's all. All right.
On the test, what do you have?
I don't remember. Now it is. All right, here's what I'd like you to do. I would like you to find the inverse of this one, and then I want you to verify that the other two are inverses. Do you remember how to verify that they are inverses?
Like plus
Oops, hold on. I don't need to run this right now. When you are graphing these, your A value is -2, your H here is 3, and your K value is 0. It's a 1/2 power, which means it's a square root function. Remember, your square root functions, this is how every one of these graphs has to look. You have got to plot the parent function. You have to. If you don't plot the parent function, it's wrong. Yeah. Always plot your parent function. Your parent function is always going to be your a value with whatever nth root you're looking at. So here your a value is -2. So when you're thinking about square roots, you just use your calculator and you're going to graph y equals -2 square root x. Okay? Your calculator will give you those 5 points. Remember, it's going to be 0, 0. The next one was at 1, so it would be at 1, -2. Next one would be at 4, so it would be at 4, -4. Next one is at 9, so it would be at 9, so we square root of 9 is 3. 3 times -2 is -6. All right, so that's your parent function. Okay? From there, you have to shift it. What do you shift here? Which way is that way? Right 3. Just move all these points to the right 3 points.
Wait, for your A, is that negative?
Yeah. And there's your new graph. Okay? You've got to plot the parent and the shift. Okay? Remember, when you're graphing the parent function, just use a, whether it's a square root or a cube root. Your table function will give you an easy set of data points and go from there. When you're doing cube, you do the cubes. Remember, your values that you're going to use are going to be 0, plus minus 1, plus minus 8 for your x values. All right, those are all your perfect cube roots to start out with. After this section, it was just basically the solving equations, which you guys kind of flew through. If I were you, I would just go into my book. I would go through the chapter review. That's kind of what I was just looking at here. It just kind of go through. So these are what, page 457, 456-ish. Just straight in solution stuff like that. Don't worry about the stats stuff. We're not going to do that. There are some chapter test problems. If you guys are looking for more of the weird-looking ones, if you want to go into there. Remember how to do composite functions, f plus g or f of x, g of x things. Those were, I know we didn't spend a ton of time reviewing that, but if I want to do f times g here, remember that means you're just taking this equation times this equation. F plus g, f of x plus g of x, you just add them together and simplify, right? Those, remember composites, were very, very, very simple. You guys flew through those. But just take a look through these, maybe 1 through 28 for just some good practice problems, things like that. If you got questions, just swing by in the morning. I will be here probably about 7:15 at the latest, after I drop off the boys. Tomorrow's Ryan's birthday.